Hello, my name is Reinhard Pottmann, and now we are talking about creating a physical storage design for Horizon. Let's do a small recap about the underlying infrastructure, basically vSphere. So what do we have? We have our management layer, as you can see on the slides. Basically, this is our vCenter, right? So vCenter is managing all of our ESXi hosts and also our ESXi servers. Our ESXi servers are our virtualization infrastructure, and this is the ESXi host is the software which is running our virtual machines, which you also can see there, which are also being managed by the vCenter. Our ESXi servers are connected to the network and also to the storage networks, which is providing the storage for our ESXi hosts. There are typical types of storages, like NFS storages, fiber channel over Ethernet, direct attached storage maybe, but not so useful in a cluster environment because we can't use our shared features on those local storages. All of the storages which you're actually using are basically shared storages, and they also should provide those data stored in a highly available manner to your ESXi hosts. In this video, we are going to take a closer look only at the storage aspect of this whole environment. Storage performance, especially for Horizon, is key. You should always aim for low latencies, milliseconds, better sub-milliseconds. And there are also some other aspects you need to take care of. Storage capacity, how many data stores do we need, and especially in view environments, if latency goes too high, user responses are too slow, users will complain. This is key. I can't stress this enough. So how can we collect then our data? Well, either you measure that, use reference architectures, have measurement tools in place, but you need to get a grip or a little understanding what performance data is being needed to achieve the workload you are targeting. Do an assessment, do a POC, and do several workloads during that POC so that you get an understanding how is your environment working with your applications in your environment, and is this fast enough, is it suitable for your business needs? Because at the end of the day, it's all there just to support your business needs. After you have collected all the data, you look at the I/O latency, you look at capacity, and also the number of data stores. But you have to put that all into in the meaningful relation. So what do I mean by that? Okay, let's go back a couple of years and look what we had there. We had small SSDs, magnetic drives. Right? So SSDs have been also very expensive. If you do the math and you look at all of the numbers, maybe you say, okay, SSDs are working because they have low latency, they are blazingly fast, but I need very many of them because the capacity of each SSD was very low. Then you look at magnetic disks. You got them for a relative reasonable price, but they are not as fast as an SSD. So maybe you could have only a couple of those and could satisfy the storage needs from the capacity side, but not from your IOPS side. So you always had to balance those factors out. It always comes down to a number, and the number is easy. That's money, right? So I can't tell you what you really need to buy, what you're really going to use. I can only tell you what do you need to have your focus on. So you have to balance out I/O performance versus capacity. Those things are different between SSDs and magnetic disks. This has a little bit leveled out over the years because SSDs got bigger, they got better. We get better pricing on those. And on most storages nowadays we have all flash anyhow. So we're just running all of our workloads on SSDs. But sometimes you maybe don't have the choice. So in that case, you just need to focus on these parameters too. If you're using shared storages, you also need to take a closer look. What RAID labels do I have? How many data stores do I have? And all of the other stuff, because different RAID levels have also an impact on the performance. Now we are going to talk about different virtual machine files and where are they located. And if we look a little bit closer at the table, we have full clones, linked clones, replica disks of linked clones, instant clones, persistent disks, and disposable disks. Most of those are placed in the working directory of a virtual machine, but we have options to place persistent disks and disposable disks on different data stores, maybe because of performance reasons, capacity reasons, and stuff like that. So this information also is going into your storage design and considerations. Where are you placing those files? If you look now on the slide, we are going to talk about storage consumption. Basically, we start out with a data store which has a number of gigabytes of free space. If we put, let's say, in this example, 10 virtual machines on a data store, and those virtual machines are using a percentage of 100% in the Delta disk, how much data will be placed on the data store and how much is then left. So it's basically a small glimpse into the future. How far can we go? How much capacity do we have left? So this formula gives you a rough estimate. And basically the formula is reading out the number of VMs you have, 50% of the replica disk plus the memory of the VM is being added together and then multiplied by the number of VM plus 2 times the size of the replica disk when we are projecting 50% utilization of the Delta disk. With the rise of the instant clones, which is the new technology which came with Horizon 7, those instant clones require significantly less capacity on data stores. They are being forked with the VM fork technology out of a living virtual machine called the parent. So a user is logging on, working with the VM, logging off, and an instant clone is then being destroyed, and the new one is being instantiated. So due to the short-lived lifetime of an instant clone compared to other VMs, we don't need things like SA sparse disks and stuff like that. Okay? So instance clones are basically only there for consumptions. User logs on, is working with it, logging off, instant clone is being destroyed, a new one is rolled out. So we are still with data sizing requirements. If we're talking linked clones, instant clones, we need capacity for all of them, right? So if you have a shared storage, you're using your data store, which is located on a LAN, on a storage box, and those storage boxes have different features, compression, deduplication. But the implementation of different vendors of those features, and so your mileage may vary how far you can get. Because if, let's say, vendor A has a better deduplication and compression ratio than vendor B, you could place more virtual machines on the same data store. So you also have to keep those things in mind. So refer to the vendor's documentation to do some tests and run test workloads on it. And for those calculations and tests, you also have the VMware VDI calculator or third-party calculators at your disposal. But always do a reasonable test or pilot so that you can see how far you really get. On the last slide, we are going to talk about if, let's assume, we have local storage on our ESXi hosts. We could leverage that. We can place our swap files on the local storage of the ESXi host. This is pricing-wise very reasonable, so we can use it. But always keep in mind, where do I place which VM file on which data store? For example, If you place the local swap file on a local data store of an EXI host, this local data store is only accessible by this host who owns the hard drive, not by any other one, because it's a local data store, right? So, when you're migrating off the virtual machine from this host to another host, what happens? The swap file needs to be transferred to the destination host, and this takes considerably more time. Of course, there is also a storage impact, because we never want to actually use the swap file, but it's being created unless we allocate the memory in full. But upon creation, there is I/O traffic going on. Maybe the swap file is being used, and there is I/O traffic going on. And this I/O traffic is not hitting the shared storage in that case. So you can, with some respect, decrease the load on your shared storage and put the load on the local data store. But anyhow, all of your planning, all of your design should always go in the direction that we do not use swap. But sometimes we don't have enough memory in our hosts. It can be swapping, it can occur, and in some cases will occur. The swap file is being created almost always, except when you're using full memory reservation.